Imagine Earth 4.6 billion years ago. Not a blue and green oasis, but a fiery ball of molten rock. This was Earth's infancy, a time of intense heat and chaos. The planet was a swirling mass of molten material, constantly bombarded by asteroids and comets. This bombardment generated even more heat, keeping the surface in a constant state of turmoil. It was a scene of unimaginable violence, a true inferno. There were no oceans, no continents, just a sea of magma under a sky choked with volcanic gases. It was a hostile and alien environment, far from the life-sustaining planet we know today. Yet, within this chaos, the seeds of our planet were being sown. The constant bombardment, while destructive, was also delivering water and other essential ingredients for life. This early Earth, though a hellscape, was a crucial stage in our planet's evolution. It set the stage for the remarkable transformation that would follow. From this fiery beginning, a planet capable of supporting life would eventually emerge. It's a story of incredible change, a testament to the power of time and the universe's grand processes. But Earth's story began even earlier, with the birth of our Sun. Picture a vast cloud of gas and dust, a nebula stretching across unimaginable distances. This cloud, cold and dark, held within it the potential for stars and planets. Gravity, the great sculptor of the cosmos, slowly drew this cloud together. As the cloud contracted, it began to spin faster and faster, like a skater pulling in their arms. The center of the cloud grew denser and hotter, a glowing ball of hydrogen gas taking shape. Finally, the pressure and temperature at the core became so intense that nuclear fusion ignited. The Sun, our star, was born. This momentous event flooded the surrounding space with light and heat. The Sun's powerful gravity began to shape the remaining gas and dust, pulling it into a swirling disk. This disk, known as the protoplanetary disk, became the birthplace of our solar system's planets, including our own Earth. Within the swirling protoplanetary disk, a remarkable transformation was taking place. Tiny dust grains, remnants of the original nebula, collided and stuck together. These clumps, drawn together by electrostatic forces, grew larger over time, forming pebble-sized objects, then boulder-sized, and eventually kilometre-sized planetesimals. The early solar system was a chaotic shooting gallery, with planetesimals constantly colliding. Some collisions were destructive, shattering these fledgling worlds, but many were constructive, with planetesimals merging and growing larger. Over millions of years, this process of accretion led to the formation of protoplanets, the precursors to the planets we know today. Earth, too, grew in this chaotic environment. Each collision brought more material, adding to Earth's growing mass. The energy of these impacts, converted to heat, kept the young Earth in a molten state. This period of intense bombardment, while violent, played a crucial role in shaping our planet. It delivered water, essential for life, and helped to differentiate Earth's interior, setting the stage for plate tectonics and the dynamic geology that characterizes our planet. Section 4. The Hadean Aeon, a hellish cradle. The Hadean Aeon, named after the Greek underworld Hades, was a time of intense heat, volcanic activity, and frequent asteroid impacts. It was a period so extreme that it makes the most violent volcanic eruptions today seem tame in comparison. The surface of the Earth was a sea of magma, constantly churning and bubbling under a sky choked with volcanic gases. The bombardment of asteroids and comets continued relentlessly, each impact releasing tremendous amounts of energy. These impacts carved out enormous craters, melted the surface rock, and sent shock waves through the planet. The atmosphere, thick with volcanic gases and vaporized rock, would have been unbreathable for any life forms we know today. Yet, amidst this chaos, a crucial ingredient for life was being delivered to our planet: water. Asteroids and comets, icy remnants from the outer solar system, bombarded the Earth, depositing their precious cargo of water onto the hot surface. This water, initially vaporized by the heat, eventually condensed as the Earth began to cool, forming the first oceans. Section 5. Birth of the Moon. About 4.5 billion years ago, a cataclysmic event occurred that would forever shape our planet, the birth of the Moon. A Mars-sized protoplanet named Theia collided with the young Earth in a fiery embrace. The impact was colossal, releasing more energy than billions of atomic bombs. Debris from both Earth and Theia was blasted into space, forming a ring of molten rock and vaporized material around our planet. Over time, this debris coalesced under its own gravity, eventually forming the Moon. This impact had profound consequences for Earth. It's believed that the impact tilted Earth's axis to its present 23.5 degrees, giving us our seasons. The Moon's gravity stabilized Earth's rotation, preventing drastic wobbles that could have led to extreme climatic shifts. The Moon also played a crucial role in the development of life by influencing the tides, which may have played a role in the origin of life in Earth's early oceans. Section 6. Earth finds its layers. As the early Earth cooled, a process known as differentiation began. This process is similar to what happens when you shake a bottle of salad dressing. The heavier ingredients settle to the bottom. In Earth's case, the heavier elements, primarily iron and nickel, sank towards the center, forming the planet's core. Lighter elements such as silicon, oxygen and magnesium rose to the surface, forming the Earth's mantle and crust. This differentiation into layers was a crucial step in Earth's evolution. The molten outer core, constantly churning due to Earth's rotation, generates our planet's magnetic field, a protective shield that deflects harmful solar radiation. The mantle, a thick layer of hot, solid rock, churns slowly over geological timescales, driving the movement of tectonic plates. This movement, known as plate tectonics, shapes our planet's surface, creating mountains, volcanoes, and ocean basins. The outermost layer, the crust, is where we live, a thin, solid skin floating on top of the churning mantle. Section 7. From Fire to Life. As the Hadean Eon ended, Earth transitioned to a calmer environment. Volcanic activity decreased, bombardment from space subsided, the Earth's surface cooled, forming the first continents. Water vapor condensed, forming the first oceans. The atmosphere evolved with nitrogen and carbon dioxide. This set the stage for the emergence of life. Life arose during the early Archean Eon. From humble beginnings, life diversified and evolved.